Let's talk about the state of internet delivery in the United States, bitrate. Where do we stand? What's the capability right now? We hear a lot about 4K, we hear about, huge demands. Where do things stand now?
So at Akamai we're seeing, first of all, we have a relatively large swatch of a network. Okay, so our samples are incredibly huge. As far as bitrate, which is so important to the audiences, we start seeing growth not only in the overall traffic on our network, but growth on the individual bit rates. This 2014 data, we saw about 2.3 megabits average bit rate being streamed, but we're seeing a lot more audiences for a lot more devices growing to 4 and 5 megabit streams on the journey to a 4K experience, which might be around a 12 megabit stream. And what's really interesting about Akamai is last year we topped out at about 33 terabits on our overall global network. What makes that even more interesting is what we've seen historically, is when we hit a peak like 33 terabits at Akamai, the following 18 months becomes the norm. And that's the most representative thing on how much this is really taking off in the market. So if you think about 2 years ago, our peak was 26 terabits. That became steady state in 2014. Last year our peak was 33 terabits. We expect that in the next 12 months to become steady state. So this year maybe we might see 50 or 60 terabits of traffic. That 2.3 megabit stream that everyone's encoding for will quickly become a 3 megabit average, and then a 3.5 megabit average, and then a 4 megabit average. More devices, more people, more high-powered displays. That's really what's driving this growth.
And what are some of the challenges in meeting that demand, sort of at the consumer level, at the household level?
Sure. Well, it's always going to be, for us, it's always going to be content localization. We know that if we get content closer to the edge, ideally even in the home, you're able to have a much better visual experience. Akamai is really trying to solve for quality at scale. And to your point about what are those driving characteristics, what really is important, we're trying to solve for a number of things when it comes to quality. First of all, we try and solve for that localization. We try and solve for the highest bit rate possible. We try and solve for the shortest startup time. And of course, the least amount of rebuffers in a video experience. We're trying to nail all of those dimensions when we deliver content for our audiences. We see a lot of growth, obviously, in the video, the broadcast space. A lot of push to linear. You're seeing that all over the place with recent developments in a variety of different national broadcasters. So live linear. We're also seeing a lot of growth in the gaming space. Now, that might not be super interesting to you, but there's definitely a convergence of the broadcast networks and the gaming networks because more people are doing more things with more devices. So you have the social networking aspect, you have the gaming and software download aspect, you have more apps being delivered, you have more video being put into those apps. Akamai kind of finds himself right in the middle of all of those different dimensions of content delivery. But video is continuing the growth of individual bitrate, and those are all very interesting. Octoshape actually brings really two dimensions to the equation. The first dimension is on the ingest side. Okay, getting content, holding true the moniker of garbage in, garbage out, getting content to the Akamai network in the best format possible is an imperative. Octoshapes technology at Akamai is going to enable that ingest plane to be more robust. Let me give you an example. If you're encoding a 10 megabit stream for internet delivery, what we want to do is we want to use the Octoshape technology to utilize the UDP protocol between the encoder and the Akamai network, and then handle all of the traffic over the Akamai backbone from points to points to get that localization, and then hand that off to a client experience using UDP, using other forms of client-assisted delivery to really drive that 3.5, that 5, that 6, that 9 megabit stream, making those higher bit rates possible at the edge.